Hey guys, I wanted to review the one-to-one and onto functions with you guys since there was a little bit of questioning today about it. So I want to take a minute just to go over that briefly. For one-to-one, and this is kind of like the mapping, I just didn't draw the circles around the numbers. For the domain subset, we've got domain values 3, 2, and 1, and then our range we've got 0, 5, 7, and 9. And for a one-to-one, basically each domain value is going to be paired with a unique y value. So what that means is you might have something that looks like this, where you've got 3 paired with 5, 2 paired with 7, and let's say 1 is paired with 0. So you've got each range value being paired with exactly one domain value, or vice versa if you want to look at it that way. We do have one that's not being used, but that is okay. That would be a one-to-one. There is nothing being repeated there. For an onto function, every domain and every range value will be used again, but we will have something, we will have a range value that can be used twice, for example. So let's say 1's paired with 20, 2 is going to -3, and we've got 3 being paired to 5, and we've got 4 going to 5 also. So that would be an onto function. Each domain value is being paired to a range value, but you do have two different domain values that are being paired with the same range value. Okay. If it is both one-to-one and onto, then they basically each element of the domain is being paired to an element of the range, and so that meets the onto requirement, is that both basically each domain and each range are being paired together. That makes the onto requirement. For it to meet the one-to-one requirement, that means nothing is being doubled up. So we could say 7 goes to 5, 3 goes to -1, 0 goes to 4, and -1 is going to 12. So that would be an example of a function that is both onto and one-to-one. Okay, let's look at a different example here. So we've got the set of pairs -6, -1, -5, -9, -3, -7, -1, 7, and 6, -9. If you wanted to map this so that you can get it to look like this, that is fine. And I can do that for you. So we got -6, -5, -3, -1, and 6. And then for our range values, we've got -1, -9, -7, and we've got a +7. So for this, you can already kind of see it's kind of looking similar to that onto function, because we've got both the the -5 and the +6 being paired to -9. And what that would look like, we've got -6 paired with -1, -5 paired with -9, 3 goes to -7, -1 goes to 7, and then we've got 6 that's also being paired to -9. So as you can see, this one looks very similar to onto. So for this set here, you might have a series of questions. Is it a function? That would be yes. We do not have any repeating domain values, so that makes it a function. Is it one-to-one? That would be a no, because we have -5 and 6 are both paired with the -9 range value. Just a minute. And is it onto? The answer to that would be yes, because every X has a Y. So more or less, everybody's got a mate. We've got the -5 and the +6 both sharing the -9, but that's okay. That keeps it on 2 because everything has a pair, or every domain has a range value that is paired with it, but it's not 1 to 1 because we have both of these domain values being paired to the same y. So hopefully that clarifies it just a little bit. If you guys have any more questions, we can address those in class. Hopefully that helps.